This is it. This is the accumulation of Unit 1 adding and subtracting integers, drawing a number line when we did inequalities back in Unit 3, making a table in Unit 7, and now this is it. This is us taking all of this stuff and putting it together with the simple idea that we plot the points on a graph and it makes a pretty neat picture. Now granted, a straight line might not seem as entertaining to you as it does other people, but it's all about that. So here we go. These are the most common linear lines that you're going to see. There will be a special case video after this one. Please watch that one as well, because that is going to have some different cases that could still show up on a test. So we're going to talk about some pretty standard looking normal lines, linear lines. And linear means straight line. So if you cannot take a ruler, which by the way, we have a ruler, pencil, colored pencils, and an eraser for big mistakes. Bam. Please have this stuff on hand, because this is going to get real. Oh yeah. Here we go. Graphing linear lines. Step 1. You get to choose your own destiny. You get to choose what you want to use for inputs. Up to now, I have been telling you you're going to use this for an input, you're going to use that for an input. Not anymore. You get to choose which input you want to use. The only thing you don't get a choice on is you have to use 0. End of discussion. Because 0 gives you the y-intercept. And that is massive, and I will definitely point that out while we're doing this. After that, choose a negative and a positive. Get a good balance, because you want a nice picture. And the more points you use, the better your picture. And the fourth thing is, if you have a fraction in front of x, because you're going to multiply, so that means you're going to end up multiplying by a fraction, you want to choose a number that's divisible by the denominator. If you have that case, and that's something that'll help your picture look better, or you might just have to modify your picture and have fractions on your number line when you make your graph, which is fine also. But I personally, I don't like dealing with fractions on a graph. They always drive me up a wall. So here we go. By the way, yes, 3 points basically. 0 always, a positive, a negative. Obviously, I do them in order. I always do a negative, 0, and then a positive, because negatives are smaller, work my way up, technically. And that's basically 3 points. Can you do more than 3 points? Absolutely. I totally encourage it. The more points you choose, the better your graph will look. End of discussion. Linear lines, you have to have 3 points. When we get to quadratics, I'm pretty big stickler about having 4 or 5 points. We'll talk about that when we get to quadratics and cubic functions, because those get a little weird. So here we go. I've taken the liberty of choosing certain numbers for certain things, but for example number 1, we are going to do this one completely from scratch. This will be the only example from linear graphing and quadratic graphing and cubic graphing that I'm going to do like this, because really, this lesson is not about me teaching you how to make a table. You should know how to do this already. Here we go. X, 2x plus 1, y, x, y. Because this is the goal. I have to have the ordered pairs. That is the whole point. By the way, I'm going to fly through this because this is something you should already know how to do. I'm going to choose a negative. Let's go with negative 1. 2 times negative 1 plus 1. Well, that's equal to negative 2 plus 1, which is equal to negative 1. Y is then equal to negative 1. And my point is negative 1, comma, negative 1. So that is my first ordered pair. Awesome. Let's go with 0. And I'm going to draw a line to signify this is a new number. 2 times 0. Why am I using 0? Because it gives me the y-intercept. Because if x equals 0, whatever y equals, that's the y-intercept. Super powerful. 0, 1. Cool. And so that's our points right there. There's 2 good points. Excellent. You just probably saw in my eyes, I thought I messed up for a second. I did not. I'm good. And I have one student in mind who's going to be like, oh, you messed up. She has said this 5 times in the past month and a half, and I've only made 1 mistake, not 4 or 5. So in your face. I messed that up. Let's go with 2. Change it up a little bit. Is equal to 4 plus 1, which is equal to 5. Cool. 5 is my y, so we got 2, 5. All right. So this is all great and everything, but the whole point of this was to get those 3 ordered pairs. That is the whole point of this. So I'm going to draw a line to signify I'm good with all this. Kind of separate this area. And now I'm going to plot my 3 points. Here we go. Ruler. Gotta have a ruler. I am going to use the ruler whenever I make a graph in class because this is going to help me. I will also use grid paper. If you own grid paper, I highly recommend bringing it to class or going to Staples and buying some. Here we go. How you do it is up to you. I do this. I'm going to measure it out. I'm going to base how I designed this on what I used. I used -1 and 2, and I got -1 and 5 as my output. So I need to have my x go from -1 to 2, and my y go from -1 to 5. Because that is the window, that's my domain and range, and that's what I'm going to do. So we're going to do this. And every millimeter, by the way, I have it on the millimeter section if you can't see that. Millimeters. I'm going to put a tick mark because it's evened out. The better your picture is, the more time you spend on it, the better it's going to end up. Hands down. I'm now going to do it this way. Say right there. I line it up with one of my tick marks. I'm going to change that to a half. I'm going to go to 0.5 millimeters because I'm not going to have enough space to do a good job on this. Every 0.5 millimeter. And by the way, yep, make sure you got enough room to do this stuff because, man, it gets tricky. 0.5 millimeter tick marks. 0.5 millimeter tick mark. 0.5 centimeter. Okay, that was my one mistake. 0.5 centimeter. Okay. So here's my coordinate plane. There are some rules I have. 1, these are 2 number lines put together. This is like a number line and then another number line shoved through it at a right angle. So we have to have it labeled X and Y. It has arrows. They are lines. This technically goes on forever. It is a line. It does not stop. A line segment stops, but not a line. So if we draw a line, it has to have an arrow. The next thing is I have to have my units on here. So I'm going to say this is 1, 2, 3. So like just to show this is 1, this is 2. You put together the rest. This is 1, 2, 3. Notice I'm not going crazy showing numbers all over the place. Can you do that? Yeah, that's fine. Am I going to do that? No, because I think that makes my graphs look like garbage. So, personal opinion. I'm going to graph my first point. -1, so back 1, because that's X. Down 1 for Y. Cool. 0 means I don't go left to right, and then 1 means I go up. So again, this is -1, -1. This is 0, 1. Awesome. And then 2, 5. I go over 1, 2, up 5, 3, 4, 5. And so this is 2, 5. So if I've made my graph correctly, if I've taken time to do my tick marks with a ruler, then I should have all 3 of these points on my line. This I call the ruler check. I haven't drawn anything. I'm waiting. I'm making sure all 3 dots are barely on the ruler. That is so important because if one of these dots is over here or wherever, I messed up. I need to fix it. I'm also not going to just do this and go, da, da, da. That's my line. What about all this graph down here? use the entire graph that you just drew. Commit to it. Hands down. Use that entire graph area that you just created. Stick to it. And it's an equation of a line. It's a line. These are lines so they have arrows. This has to have arrows. End of discussion. Has to have arrows. So, that is a linear line. And that is my phone going off, as it often does. Okay, turn that off. Sorry about that. Turn your phones off next time for video. Check. Okay, so that is a linear line. Awesome. And that's our first example. Very nice picture. Used a ruler, pencil. Colored pencils got forgotten. Gonna use that in the next example. My bad. Example number 2. We have 3 examples. I gave 4 rules. I'm asking you to graph the equation y equals negative 2/3, yes, that is a negative, negative 2/3 x minus 4. That is a fraction in the front, which means I'm going to be dividing eventually. If we're going to be dividing, we need to pay attention to what we are dividing by. The denominator, 3. Whatever input I choose, so I chose -9 first, I want it to be divisible. -9 divided by 3 is -3. -2 times -3 is 6. Now I have nothing but whole numbers right here in my point. If I don't choose something, if I choose like 7, 7 divided by 3 is not a nice number. Then I have to deal with a fraction on a number line. And that's not an entertaining experience for me. I'd rather not. So keep that in mind. I'm going to just zoom this out to show you what I chose for my points. So basically, here's the table. Copy it. Pause the video in a minute. Copy it. Autofocus that. I plugged in 0 and got -4. I plugged in 6 and got -8. These should make a number line. Cool. Here's my graph. Woohoo! Pre-made. All right. This see grid paper, dudes. I will let you know right now when we get to geometry, I will redo a few videos because I am the worst artist in the world. Rulers save my life every single time. All right. So I want negative, if you look on your other notes, -9, +2. So I'm going to remember, I got these fancy color pencils. Oh yeah. Oh yeah. Fancy color pencils. Fancy color pencils. -9, 2. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my point. -9, 2, up 2. 1, 2. So that is -9, 2. And I'm going to put this right there. -9, 2. Awesome. I also have 0, -4. So not going up and down to anything. I'm just going down to -4. 1, 2, 3, 4. That's -4 right there. So again, 0, -4. Hey, that just hit the y-intercept. That's my y-intercept, by the way, of the line, because it's going through there. Cool. And then 6, -8. So I'm going to over 6. This is 4, 6, 7, 8. So there's my graph. Notice I am putting my points on there. I'm labeling them so I know what's what point in case there's a problem on my test. And I'm going to do my ruler check. Look how good that looks at the graph, the grid. Oh man, it looks so awesome. That looks sweetness by me. Oh man, look how good that looks. Oh, that looks awesome. I love this. You will get some math history in class, because man, this is like, oh man, if you want to look up Descartes, because this is all him. God, I love Descartes. Okay, there's my equation for the line y equals -2/3 x minus 4. Awesome. That's my second example. Now for my last one. This will look familiar. That should send tears up, chills up your spine if I ever say that in a video. Here we go. We're gonna fill in a little bit of this table because I didn't do everything for you. I'm asking you to graph negative x plus 4. Y and my x, my table. This gets a little weird. Negative x is a weird number because when I plug a number in, what happens? That's a great question. First off, parentheses, every single thing you've seen me plug in, I have used parentheses because this gets really confusing right here on this type of a problem. What happens to a negative and a negative? If you don't remember, and I've said this quite a few times throughout the year, anytime you have parentheses or a variable or an absolute value or something with just a negative, it is not just a negative. It is the number -1. They don't put it there because of the multiplicative property of the identity of the multiplicative property. Multiplicative identity. There's no property. Multiplicative identity. They don't put it there because they don't have to. 1 times anything doesn't change. -1, that changes the world. A negative times a negative is a positive. 1 times 3 is 3. Now it does all sorts of crazy things. 3 plus 4, now it's 7. That is huge. Don't mess that up. That will ruin your day severely. There's the rest of the table. Copy, copy, copy. Go ahead. That's it. Just because, well, yeah, there you have it. We are going to make our graph now. Shazam! Graph done. Yay! Cool. Okay, here we go. Let's graph some points. First point I'm going to graph is -3, 7. So, oh, did you notice how I did my graph differently? I went every other tick mark. As to, you also notice I apparently can't add because that's supposed to be an 8. Your teacher's an idiot. Okay, -3, 7. Here we go. 1, 2, 3. Every tick mark still counts for 3. It's just I didn't mark every single one. It makes my life, there's so many different ways. Also, yes, there is no arrow up here or down here. Good catch. -3, 1, 2, 3. Up 7, 1, 2, 3, 4, 5, 6, 7. Mr. V, use some colored pencils. Heck yeah, let's make this look good. Okay. Next point is 0, 4. Yeah, I'm looking at my table, by the way. You should be looking at your table. Make sure I said that correctly. 0, 4. Here's another point. And my last point I got on my table is 2, 2. It is not in a 2, 2. It is just called 2, 2. Ruler check. I take my hand away. I make sure, yep, that looks like that's a straight line. All the dots are there. Yes. I did not label it. I'm going to add a point. You can see, by the way, when you make your graph, you should be able to pick out other points. There's another point right here. That is 4, 0. If this is called the y-intercept because x is 0, this is called the x-intercept because it hits the x-axis. So that is called the x-intercept. Really cool trick with the graphs that I can find points on the graph also. Crazy. All right. That's that. That's how you go from an equation to a graph. Before the end of this unit, you are going to go from a graph and make the equation. Can't wait. That's this section, graphing linear functions. Enjoy. I love pictures. Make your pictures big and good. I don't want no tiny pictures. Big pictures.